Hello and welcome students to the ninth lecture of this course, which is named chemistry, having the course code of CH101 for our semester and CH201 for even semester. I'm G. Chakraborty from the Department of Chemistry and welcome you to this ninth lecture. Right now, this ninth lecture starts with a new module. Before discussing about that, let us see what we have seen in the last 8 lectures. So in this last 8 lectures we have seen multiple things. Now what that multiple things mean? See, the last 8 lectures belong to the first module, which is called inorganic chemistry, and as you know that inorganic chemistry deals with different atoms and molecules, their structure, periodic table, bonding, etc, etc. So in this 8 lectures, what we people have seen, basically, the module 1 inorganic chemistry was divided into 2 parts. One is the atomic structure, another is the periodic table or periodic properties, right? In the atomic structure, there were the first 4 lectures, 1 to 4, and in the periodic properties, there were the next 4 lectures, 5 to 8, right? Now, in the periodic table, we have seen the details of the periodicity of elements, the laws, etc, and all, whatever have been present. In the atomic structure also, we have seen multiple atomic models and all. I'm not going into the details of these things because we have more things to discuss here in this particular lecture. So this particular lecture is actually the module 2, first lecture of the module 2, right? And the module 2 is named none other than physical chemistry. Okay. Now, as you know that physical chemistry contains large number of topics. The first and foremost, the most important topic of this physical chemistry part is nothing but thermodynamics. Okay. Now, let us see what we have in this particular lecture. So, as you can see, a big name has come up in front of you. That is use of free energy in chemical equilibrium. Now, you might be thinking that this chapter is actually equilibrium because the word equilibrium is coming, but it is not like that. AICT is a very clever organization. What they have done, previously in BTech syllabus, we used to have 8 lectures for thermodynamics and 4 lectures for electrochemistry separately, right? Because as you can see in your 12 level also, you have studied thermodynamics in class 11 and electrochemistry you have studied in class 12, okay? So that type of syllabus was there previously, but at this moment, AICT has revised this syllabus. And what they have done, they have cut down the basics of thermodynamics and they have cut down some parts of electrochemistry, okay? And they have combined these 2 chapters, thermodynamics and electrochemistry, with this horrible type of name, which is called use of free energy in chemical equilibrium. Means, as you can see, if you see how clever they are, use of free energy, this comes from thermodynamics. In chemical equilibrium, this comes from some other chapter, okay? Now, whatever it is, our syllabus is well defined and we are going to discuss about it. And this is the first part, that is a part 1 of this particular topic, which is called use of free energy in chemical equilibrium of the module physical chemistry, okay? Module 2 for the chemistry syllabus. Let's go to the next slide. Now, as you people can see, this is the very basics of the thermodynamics. This is a basic lecture in which we'll see what the thermodynamic system, surrounding, function, etc are. And accordingly, the first topic will be thermodynamic system, second topic will be thermodynamic processes, third will be functions, fourth will be properties, fifth will be first law, and sixth will be internal energy. Now, none of these topics are actually new to you because you know it very well. Okay. So let us start the first part, that is thermodynamic system. Now, what is thermodynamic system? If you come into the details, we need to know what is thermodynamics first, right? So accordingly, our definition is like this. Thermodynamics is defined as a branch of science that deals with the relationship between heat, and other forms of energy such as work. It is frequently summarized as the three laws of thermodynamics that describes how different forms of energy are interconvertible, can be interconverted. Okay. So what is the definition of thermodynamics? Thermo and dynamics, right? Thermo means heat, dynamics means movement. So whenever there will be a movement of heat in any of the cases, then thermodynamics will come into operation. And this is the branch of science that deals with the relationship between heat and other forms of energy. There is the movement of heat between one place to another, right? And basically, thermodynamics is dependent on three laws, as you people know. These are the laws of thermodynamics. Okay, so we have studied them previously, and also here we will study about them. Now, if we people go into the details that what thermodynamics is, we'll come across that one of the main important things in thermodynamics is the concept of system and surroundings. Okay, so let us see what system are. Let us see what surrounding is. See, one of the basic assumptions of thermodynamics is the idea how we can divide the universe into system and surrounding. Most common terms in thermodynamics. Now the question arises, what is system? What is surrounding? Here one definition is given. Let us study the definition, then we'll go into the details and discussion that what is a system. We'll try to understand each and everything using our own life, our own what I can say practices that we do in our daily life, so that if we relate things with life, then the things becomes easier, because now we'll be able to know that what is actually happening. Okay, so let us do that. And as you know that a thermodynamic system is defined as the quantity of matter or region in space in which the study of thermodynamics is done. Here quantity of matter may be gas, liquid or solid. So basically what we people say, we people generally say that uh, thermo system is something on which the system is something which is actually under observation or study. If you are studying something, it is, for example, we have a cup of hot tea with us. Now we are doing some experiment on that cup of hot tea, so that cup of hot tea becomes our system, and the room in which we are doing the experiment becomes our surroundings automatically, right? So it is also written here that everything external to the system is called surrounding or environment. The system is separated from the surrounding by wall or partition. Yes, in this case also, if we consider that cup of hot tea, the wall of the cup is actually the partition which prevents the system from being dispersed into the surroundings. Okay, the system and surroundings together consists of the universe. Now here also I would like to tell you one very important fact, that this universe is not the universe that contains solar system and all. Okay, this universe is a little different. Size of the universe depends on the size of system and surrounding. Now you are confirmed that this universe is different, because size of the celestial universe cannot be determined, never. Okay, so here this type of universe and all, this is quite different from thing that you might be thinking. Okay, so system and surrounding together constitutes the universe. System is something which is under study, surrounding is something other than the system, right? And boundary separates the system from the surrounding. Now it is written the boundary between the system and the surrounding can be real or imaginary. A wall may be fixed, movable, permeable, impermeable or semi-permeable, right? It's quite easy to understand that real or imaginary boundary may be there, and can be movable, right? Can be impermeable, means nobody can penetrate, somebody can penetrate, or it is penetrable. Okay, now one thing should be stated here, which is not written actually, that is there are basically two types of walls that we people are having. One is the diathermal wall, another is the adiabatic wall. Okay, now diathermal wall is that wall which allows heat to pass through it but does not allow matter to pass through it. Okay, heat will go just like the cup of hot tea, the wall of the cup. See, a time will come when the tea will be cold, right? Why? Because the energy moves out from the tea through this boundary, and it is allowed. Okay, that type of boundary is called diathermal wall. But if we keep that particular tea inside the thermos flask, then the boundary will not allow heat to pass through it. So that type of boundary is actually called adiabatic. Okay, does not allow heat or matter to pass through it, right? These are the two types of boundaries that we are having. Let us see what we have in the next page. Okay, so here we are having types of system. So as you see that I just spoken about cup of hot tea, and we have the tea right here in front of us. See, this is the cup of hot tea. Flask is also there, right? So basically there are three types of systems, as we people already know. One is open, another is closed, and third one is definitely isolated. Okay, so which one is, what is open, what is closed, what is isolated? Let us move into the details. As you can see, if we go for the open system, it is that system which allows both energy and matter. Uh, it allows both exchange of energy and matter with the surroundings. The stovetop example would be an open system, okay, because heat and water vapor can be lost to the air. But I'll not give you example of stovetop. Rather, we will discuss about again the cup of hot tea, which I need right now very badly. Just joking. So the thing is that open system is that system which allows both heat and light, both heat and energy to pass through it. Okay, it does not disallows anything. It rather allows both energy as well as matter to pass through it. Previously I said heat and energy both are same. Okay, the energy and matter to pass through it. Open system, right? Now whenever we'll move to the closed system, then what we will see, we will see that it allows energy to pass through it but does not allow matter to pass through it. So let us consider the example of this cup of hot tea. See, in the first position the hot tea is open. So what will happen, the water molecules are being lost in the form of water vapor. Okay, and also after some time the tea will get cold, so energy is also getting lost. So gradually both water molecules as well as energy are getting lost, right? That means both exchange of energy and matter is going on. So that's why it was open system. Now if we discuss the closed system, then we'll see that the tea is covered with lead, right? So now no more water vapor are allowed to escape. So mass is restricted or matter is restricted, we can say. But again the tea will get cold after some time, so energy is getting exchanged. Okay. Now if we move from this open and closed system, and if we see what isolated system is, we'll be finding out that isolated system is something which is much different from these two systems, because it allows neither heat nor matter to pass through it. Simply, if we take our cup of hot tea and if we pour the tea into a thermos flask, then the tea will be hot as well as none of the molecules will get evaporated. Okay, so that's what isolated system is, right? Now what these people are saying, let us see. Okay, if we put some very tight fitting lid on the pot, right, we have discussed about it. So isolated cannot exchange both either matter. Fine, a perfect isolated system is hard to come by, but an insulated drink cooler, which is lead, okay, fine. So whatever this is given here, that explanation of that is given. Items inside can exchange energy with each other, which is, that is why drinks get cold and ice melts a little, but they exchange very little energy with the outside environment. That is, they're considered to be isolated compared to the outside environment. Okay. So first topic over, we are going to the second topic, which is nothing but thermodynamic processes. So as you can see, there are most common thermodynamic processes about which you have been studying from class 11, that is adiabatic, isobaric, isochoric, isothermal. These four up to this particular thing you have studied in class 11. Okay. Adiabatic, you people have studied that it is a process during which heat exchange is not possible, that is cyclic integral of Q is 0. Isobaric means pressure is a constant, delta P is equal to 0, means no change of pressure will occur. Similarly, isochoric means volume is constant, no change of volume will occur, and isothermal means temperature is constant, no change of temperature will occur. Now, up to this we have studied in our class 11 also. We have seen the graph that is present right here. So isochoric is like this, that pressure is changing, volume is not changing. Isobaric is this one, pressure is not changing but volume is changing. And isothermal and isobaric are normal curves, because here it is a PV curve, right? If we move to the isoenthalpic process, what we people can see, if enthalpy change is constant or enthalpy change is not allowed, then the process is called isoenthalpy. Now from our prior knowledge, we know enthalpy is the heat content of a system, right? So this is the fifth and process of this thermodynamics. What about the seventh and eighth? Let us find out. The seventh process is the cyclic process. Okay. Now it is written that it is the one in which after a series of events the system returns back to its initial state. So it's quite common. Cyclic means circular. So from wherever it starts or whatever it does at the end, it will come to some particular place. Okay, this is called cyclic process, right? Now another is reversible. Last one is irreversible. So reversible is the one in which system goes to surrounding by infinitesimally number of small steps in such a way that change in any parameters of the system can restore the system back to its initial state. And irreversible means system once started cannot be restored back to its initial state. Now this is nothing but by giving an example, let us explain this. Now I give this example every time in the class. It's quite very interesting, right? Suppose we have 20 students with us starting from the ground floor and going to the third floor, right? The floor. Okay. Now what happened? 10 persons grabbed the lift and 10 persons were going by the stairs. Okay. Just try to imagine 10 persons going by lift, 10 persons going by stairs. Okay. Now the lift has started going up and this 10 persons who have to go through the stairs with what I can say sad face, right? They are also starting. So both have started. Lift is going up fast, but the students who are going by stairs are a little bit slow. Okay. Suddenly, what happened? One phone call came that today college will be dissolved due to this outbreak of coronavirus and all. What will happen? Immediately, the person who was going by stairs, they will turn back and they will come down. But whoever was going by lift, the lift will go up to the top floor, door will open, door will close, then it will come down. So which of the process can immediately return back to its initial state? Definitely the reversible one. That means if we take small number of infinite number of small steps and then using that if we go to the final position, then what will happen? Then definitely we can go back to the initial position, right? Because this is a stepwise concept, right? That is what we are saying, that if somebody is going by stairs, then he can easily back off because he is going by small steps. But if somebody is going by lift, he or she is traveling with huge speed, so cannot be reversed that way, right? So lift process is the reversible process, whereas going by stairs is nothing but a reversible process. Okay, this was all about the thermodynamic processes. Let us go to the thermodynamic functions, right? As you people can see, basically there are two things. One is state function, another is path function. Now state function means those functions which actually depends only on the final and initial state, but not on the path using which the system has gone from initial to final state. Means if only dependence is on the initial and final, not on the path, then it is called state function. And if along with system and not system, if along with initial and final state the system depends on the path on which it has gone, then it is called just written state function. It will be path function. Okay, this one will be path function. Just typing error. Okay, example is heat and work, example is enthalpy, internal energy, entropy. Now let us use another example. Just like what our technique is, we always use examples from our life so that we can understand it well. Suppose there are basically three types of guardians. Okay, three types of parents are there. So one type of parent is like this, that whenever you will come from school to college, when you come from home to college, then what will happen? They'll ask that have you reached college? So you will say yes. Then the guardian will be satisfied. Okay, so that means he or she is relying on is inquiring about the initial and final state only. Initial state is home from where you have started. Final state is college. Ki beta pahunche ki nahi? You have reached or not, right? So this type of guardian we may consider as state function because he or she is asking about the states only. Now there is a second category of guardian who will say that have you reached? You will say yes. By what you have reached, with whom you have reached, how many rupees was taken as fare. So different type of thing. Was the path good? Was the road good? Whether you were alone or not, right? That means there are some parents who depends not only on the initial and final state, that whether their ward has reached college or not, but they're also inferring about the path using which that person has reached, right? So that's how it is. It is the state function and path function. So if thermodynamic function depends on initial and final state as well as the path, then it is called path function. If you delete the path part, only initial and final state, then it is called state function. Okay. One more thing is there. I said there are three types of guardians. The two I have spoken of. Third type of guardian is those who will never call you or never be bothered about their word, whether they have reached or not, right? Okay. So next we are having the thermodynamic properties, and as you people can know, there are basically two thermodynamic properties. One is intensive property, another is extensive property. Okay. Now intensive property means the properties which are dependent on the amount of matter, and extensive property means with the properties which are dependent on matter, and intensive property means the properties that are independent of matter. Okay, so intensive stands for independent. Always remember this. Intensive stands for independent. Now question arises, what are the examples? So examples are mass, volume for the extensive property, whereas amount of substance, energy, temperature for intensive properties. Okay. Now by this we clearly cannot understand that what particular this thing means, but we can understand by using a simple example. Suppose you and your friend are standing in different countries. You are standing in Canada, cold country. Your friend is standing in Africa, hot country, right? And you are standing with two things, 1 liter of water and 1 ml of water. Now tell me, at what temperature water is supposed to boil in Canada and Africa? Is it different? Answer is no. The temperature for boiling for water is 100 degrees. So whatever, in whichever location you are, whatever the outer temperature conditions will be, water will boil at 100 degrees. Okay, there is no change. So it is independent of the amount, right? It is independent on the location also. If whether you are having 1 liter water or 100 liter water, it will boil at 100 degrees, right? That means temperature is independent property. But if we depend on this particular thing, volume, okay, now whatever time, or we can say time also, whatever time 100 liter water will take to boil, same time will be taken by 1 liter water. Answer is no. It will take different time. So it is extensive property, right? So that is how extensive and intensive property are. Let us go to the next slide. So now we are having the first law of thermodynamics, and what the first law is saying is very simple thing. First law states that energy can be converted from one form to another with the interaction of heat, work, internal energy, but it cannot be created or destroyed. In simple words, we can say energy can neither be created nor be destroyed, but can be transferred from one form to another. Okay. And a more simple word, we can say energy can neither be created nor be destroyed. Okay. And we can explain this mathematically by this particular equation, delta U equals to Q plus W, or Q equals to delta U plus W, right? Where we can write, in place of W, we can write PdV, because PdV is nothing but external work. Okay, mechanical work. For adiabatic process, U is minus PdV. For isothermal process, Q equals to plus PdV. Okay, so that's how it is. Very simple thing, the first law of thermodynamics. Now first law is called the law of internal energy, because internal energy is the basic thing of first law. Now we need to know what internal energy is. Internal energy is the internal energy that is present, right? Confused? It's not confusing. Again, we need one good example. Okay, suppose you are having 10 kg wood with you, or 10 kg coal with you, right? Just try to remember, 10 kg coal you are standing with. Okay, now you have lit a matchstick and you have given that particular fire into the coal and the wooden heap, and that particular thing burns for 5 hours. Now tell me, you have given little bit amount of fire, how this particular thing is burning for 5 hours or 4 hours? How? That means some amount of energy was located inside that coal, and that particular energy is called internal energy. Okay, so we can go for some examples. What is written? It is internal energy of a system may be defined as the sum of all possible type of energies, like kinetic energy including translational, rotational, vibrational, and potential energy like nuclear energy, chemical energy, electronic energy, etc. The thing will be denoted by U or E, and when a system changes from thermodynamic state A to B, the change of internal energy will be denoted as UA, and UV respectively for this state. So delta U will be UV minus UV, nothing but final minus initial. Okay. Now two more things are there. Internal energy is a state function, and change in internal energy is path followed. Means it is what? Internal energy is a state function, but change in internal energy is independent of path followed. That means it is definitely a state function, and it depends on the initial and final state of the system. Okay. So internal energy is nothing but state function. Now there are characteristics of internal energy, and what these characteristics are, let us see. First one is saying internal energy depends upon current state, but that is condition. We know this very well, that it is independent of a path and it is a state function. That is what it is written in the first point. Second point says it is extensive property. Third point says no change in internal energy in cyclic process occurs. Definitely it will occur, and definitely no change will be there, right? And it depends upon temperature, pressure, chemical composition. That means in the normal parameter, thermodynamic parameters, it depends. Internal energy for ideal gas is a function of temperature only. During only transformation, total energy of universe remains constant, right? This why it remains constant, because this is nothing but the law of conservation of energy. Okay, that's why. Now what we are having, mathematical expression. You can see this is actually a partial derivative, right? Either you know it or you will know it. Du is equal to du dt. See here what happens, basically one thing is kept constant and the other thing is derivated. So you can see here t is taken constant and v is derivated. The next v is taken constant, t is derivated. Okay. Also we can write in this way that delta equals to cv dt, where cv is nothing but, say, heat capacity at constant volume. Okay. SI unit of internal energy is joule, right? So that's how it is. So this was all about the lecture for today. That is the first lecture of thermodynamics and equilibrium together, known as use of free energy in chemical equilibria. And in this lecture, we people have seen the basics of thermodynamics, like processes, functions, and properties, and all, right? Open system, closed system, these things we have seen. And also we have seen what is first law of thermodynamics, and we have seen what is internal energy. Okay. So in the next lecture, we'll come up with some different topics like enthalpy and all. Till then, stay tuned and thank you so much. Read thermodynamics and stay safe. Thank you.